Yo, yo, yo. Long time no see. I've been away on some vacation, some traveling, so I just haven't had time really to start the stream, or I haven't had good enough internet to start the stream. But yeah, now I'm back, so we'll start streaming more again. "39 seconds for this. Way too long." All right, so there is this huge problem with, I mean, this is really cool that 3D terrain can be generated, but it takes way too long to generate it. That is a problem. I'm actually not sure if this is good, that the edges are filled in. Should probably be empty. And why is this empty here? There are a lot of problems to solve, to be fair. This is cool though, that the slope of this hill is very smooth. So yeah, last thing I was doing was trying to figure out where the bottleneck is. So I removed create underground. So what did I change? Let's see where we are. Gate status. What's the latest commit called? Hey Arch, what's up? Yeah, I've been away for a bit. I've been traveling, had a vacation, so I have not had the chance to stream in a while. However, I have been working some on like the airplane and um, while traveling and a little bit in the evenings. Moved to array, so that is the latest commit. How have you been, Arch? All good with you? So I'm thinking one reason for the bad performance is that we're generating stuff that the player doesn't even see. Would it be possible to just show or just generate everything that the player sees, and then if he or she would dig a hole, we move the generation there? Yeah, so it's performance tuning, like generating this small little piece takes 33 seconds, and that's way too long. Ideally, it's like that. But it's not. So I think that's too long of a time period because it has to scale. And I'm not sure how other games do it. Minecraft generation performance. Yeah, I generate everything you saw there first. Stacks of 16 chunks. Cube made of 16 by 16 by 16 blocks. I want the chunk columns within a certain radius to render. Each tick I check which chunk columns are within radius of the player, then render them. Yeah. It freezes. Single chunk instead of a whole. Within a certain radius. Rather, yeah, I mean, it's not the entire world, but everything you saw, like everything here. So I would like this to be different chunks of the world. Like in the flat version of the game, the previous version of the game, there are 3 by 3 chunks. Like that. And then if the player moves here, the generation will come with him or her like this. And create these new ones. And then these ones will be removed or put back into memory when the player moves like that. But to do that, I still need to improve the performance by quite a lot. Building the entire visible world every update. Creating new game objects for all the visible block quads each frame. Statue all of your game objects once after you define your world chunks column, then set active. Yeah. Because like the current world, it's like 55 by 55 in every chunk. Some block games like Minecraft don't generate the bottom at all, but only if you mine it, then they generate the blocks. With that, it might be hard to add cave structures. Yeah, that was what I was thinking about. I want the player to be able to dig a tunnel, and if a tunnel is dug, how does the game know that it should only render these and nothing else? Because we can't then just go for every block and check what's the first thing that isn't filled in, because then we wouldn't render anything here. So we need some kind of algo or something there. That goes through that. And if we have that algorithm, I'm sure we could do the same thing with pre-existing like cave structures. Maybe entirely delete the unloaded chunks and save them somewhere so you can load them back later. Pretty sure when you load chunks in Minecraft, it does something, then it saves the chunks. Yeah, save file. Yeah, I've been thinking about that as well. Like when the memory gets over a certain size, or you are far away enough from the chunk in memory, it should go onto disk. I totally agree. And then it should pick it up again when you get close. And this should all happen in the background. But yeah, I'm pretty happy about what it looks like. I just need it to become faster. And the majority of time spent seems to be in here, like in these. Fill in world grid below ground. So what if I don't do this one? And not fill in anything below ground. Yeah, it's a lot faster. Just 2 seconds. But this looks very different from whatever is underground. How is that possible? Data generation here is only 1 second. Potentially one thing that could be done is, as you said, what if we let the player, like we only generate the surface, and then we let the player dig, and we save all of the nodes that the player have dug, that have changed by the player, into a list. And then when we're rendering, we're looking in that list too. So then we would render anything that the player has kind of touched and built something in. But I'm not sure how Minecraft can be so fast. Or how long does it take to generate a new world in Minecraft? Minecraft world generation. Chunky. I watched this video, it's really good. By Alan Sikomi.
Minecraft is, in a sense, an Earth
Oh, okay, 10 seconds.
simulator with animals, oceans, mountains, trees, weather, day-night cycle, etc. Of course, there are some differences. On real Earth, you won't find floating trees and armless, cactus-like suicide bombers sneaking up on you. But overall, terrain is designed to feel Earth-like. Have you ever wondered how this terrain is actually generated?
Yes.
Well, I hope so, because that's what I intend to talk about for a while. In the Caves and Cliffs update, we radically changed world generation. The initial goal was to just add big mountains and improve the cave systems. But we ended up changing almost everything to make the world more interesting, more varied, and more dramatic. In the past, terrain generation in games was just magic to me. I didn't understand how it works. But now I've spent a bunch of time working with it and learned a lot. And I find it kind of fascinating how you can do really cool things with just some math and a few lines of code. First, I'd like to talk a bit about size. Minecraft is big. Let's compare with Earth. Earth is a round ball with an area of about 500 million square kilometers. A Minecraft world is a flat square with a surface that is about 3.5 billion square kilometers. So about 7 times larger than Earth. And that is only one world.
That might as well depend on your render distance. We'll check right now the speed on 12 chunk distance and on 2. Thank you, man.
Every time you start a new game of Minecraft, you will land in a new world. Almost certainly a world that nobody has seen before. Because there are 18 quintillion different unique worlds. That is an 18 with 18 zeros. Let's compare this with our galaxy. The Milky Way has about 100 billion planets. So if each Minecraft world was a planet, we would need about 180 million Milky Ways. It's big. Minecraft is a digital world though, not physical. Digital worlds take less space, but they do take space. Every Minecraft world is a grid of blocks. Think of it kind of like a Rubik's Cube. But instead of 3 times 3 times 3 blocks, it is 60 million times 60 million blocks wide times 384 blocks tall.
Mm.
A digital representation of a Minecraft world is really just a list of which block position contains which type of block. For example, dirt here, air there, water, flower, etc. Storing one complete world would require about 97,000 terabytes.
Oh my god.
In comparison, the largest disk in the world is about 100 terabytes, so that's not even close to enough space to store a world. If we were to store all 18 quintillion worlds on disk, we would need all hard disk space on Earth times 200 trillion or so. But yet, the Minecraft download is only about half a gigabyte. How can that be? Where are those worlds stored? Well, they aren't stored at all, not initially. The download doesn't actually include any worlds at all. It contains the code to generate the world, and that code is tiny. In biological terms, you could say that we aren't shipping a body, we are shipping the DNA with instructions for making the body. When you create a world in Minecraft, it looks like you are in an existing world that continues beyond the horizon. But that is actually a carefully crafted illusion. There is nothing beyond the horizon. When you move in that direction, the world gets created in front of you as you go. You can see it happening if you move really fast and the game struggles to keep up.
Thank you.
This approach is known as procedural terrain generation. So how does it work? As you may notice, as we move around, the world is generated in chunks. Each chunk is a vertical column 16 by 16 wide and 384 blocks high.
Okay.
The job of procedural terrain generation is to answer a very specific question. What block should we place here? It is basically a function. We can call it getBlock. It takes a coordinate expressed as x, y, z values and returns a block. When generating a chunk, we call this function for each position in the chunk. So how do we make each chunk fit with its neighbors? It is like a giant 3D puzzle where each piece just somehow magically fits seamlessly with each adjacent.
Yeah, so what if I make it into 16 by 16? What? Where did these errors come from? Invalid 6 set index 16. Okay. Why? Where is it trying to get that? That's odd. What is that? Hey, Speed Boost Boy. Yeah, it was good. It was good. Went to Italy, to Pompeii, watched the excavations, the archaeological excavations of that ancient Roman town. It was amazing. And then went to some coastal towns and had some Napolitanian pizza. It was really nice. How have you been? Right, let's try to debug this. What? Why is there no... Oh, X said Y. Same thing. Cool, cool. Are you enjoying the summer weather? Is it good weather where you are? Get height for explode set float height map. How can that not work? Why? Okay, let's try it this way. I need to figure this out. It just looks weird. Something is wrong with it. Way too hot. Yeah. Honestly, it's a bit too hot here. Like, I'm having a fan on right now, and yeah, what's the temperature? 24 degrees. It's a really warm summer. I was up north in the weekend, up in Umeå, which is pretty far north in Sweden. Usually it's colder there, but it was like 26 degrees. It's pretty unusual. Okay, at least it's generating something. And how fast did it go? Extremely fast. Wow. Okay. So let's try to generate multiple chunks. $17 for you now? Oh wow. 26 earlier, yeah. It's a bit too much. Okay, so Arch on YouTube, you're writing that we're talking about Minecraft and like how the generation can be so fast in Minecraft and trying to take some smart ideas from there. With vanilla version and no texture packs, both worlds 2 chunk distance and 5 sim, 12 chunk distance and 12 sim were both about 1 minute with difference of 3 seconds. What is sim? It's interesting that they're about the same. So it doesn't seem like it's scaling linearly. How's it going with your game speed? Your what was it? You had some suggestion for names, I remember. Yeah, it was like a trials and stuff. Right. There's too many channels in the Discord. Ascent. Right. Player going through trials. It's getting hard to code. Why is that? Two options with chunks. Chunk distance is the amount of chunks loaded around the player. Simulation distance is the amount of chunks from the player. What? That aren't loaded in rendering but simulate their blocks and mobs, etc. Oh, okay. Cool. I get it. So you're not rendering them. So it's actually not a performance boost from a simulation perspective, but rather from a rendering perspective. Okay. Makes sense. Thank you for explaining. This project is getting really hard to code as well. If y float under equals, get x, y, z. Wait. Z. No, x, y, z, it should be. Spaghetti code, yeah. I feel you. Oh, you're doing it in Scratch, right? X, Y, Z. Yes, we need the int there. Right. Maybe I need to add... So this can be really small. This could potentially be 0. Amplitude. Yeah, I'm doing the chunk thing right now. Trying to figure out how to make the chunks fast enough. So you're saying Minecraft does 12 by 12? No, it's distance, so it's like 24 by 24, or 24 times 16. 384 by 384 in 1 minute. That's a lot faster than I'm doing. For 10 by 200, it takes me like 40 seconds. So it's magnitudes slower. How can they do it so fast? They're getting the block type, sure, for every cube. So what if I do the same? Go to another location really fast on 12 chunks render. So it has no time to render others chunks. Yeah, cool, man. Thank you so much. Just heights, high-res heights. So what I probably should do is just fill it all in. Like just do like here, but also the Y. So for Y in range, Y width. It's more like a square. Okay. Yeah, I guess that's the easiest way to do it. And what I should do here is just world grid x, y, c equals get block value of x, y, c. And then we move this stuff to a get block value thing. Or will that actually work? Yeah, I'm fumbling in the dark right now. Maybe it's not the most interesting to watch, but yeah, I just have to kind of hit my head against this until I can solve it. By height. Well, I don't know why this would make it faster. It's just going to do it from a different direction. filling world below ground. Oh, you noticed some things? When you first came, it didn't load anything for a while, about 20 seconds. And then it started. Minecraft only also renders chunks that are in front of the player. Doing it on the laptop, yeah. Okay. So it takes a while for it to start. Okay, I think I will remove that. And that. And this. So that should just gonna confirm that it still works as expected. By the way, where do I set the noise type? Maybe the noise type is something we should change for better performance. Yeah, could be that it queues it up and then when it's ready, it's loading it or something like that. Okay, this is still an exported value. So let's look at it. Simplex. Oh, this is the slow one. If I take smooth instead. Yeah, look at this. It's not correct. Or no, it's just because of the mesh thing, by the way. Never mind. Okay, if I do the regular simplex, doesn't matter. It's very similar. Even faster. Okay, let's use the faster one. Where am I using octaves? Yeah, I'm not. All right. And there is definitely a problem here with the X, C, and Y are not getting represented in the correct way. How does Minecraft generate worlds so fast? Fast. Let's add some keywords. CPU and RAM. A small world in Terraria, 4.2K by 1.2K. Takes 3 to 5 minutes or so. Oh, really? So you play Terraria on your tablet. Is it fun? Valleys and hills. Composition of ore to grass and the position of these materials is relatively to the height of the 256 height limit. Caves in veins, building chunks. The despised endless mountains. Yeah, like floating islands. You don't have the Steam version? It's harder to play on tablet, okay. I have never played Terraria. But it sounds fun. So nothing here is about... nothing here is about performance, like how it's so fast. Can I make it run on the GPU or something?
Adjacent piece, no matter which order we generate them in. We'll get to that. Chunks are actually generated in steps. Here is an example. I made this chunk wider just to illustrate more clearly. The first step is terrain shaping, where we determine which blocks are solid and which aren't. Basically just placing stone or air at each position.
Yeah, that's the step I'm
Then we
at.
calculate which of the air blocks are beneath ocean or river or lakes, and fill those with water. Then we apply a surface layer, replacing the top blocks with things like grass, sand, dirt, etc., depending on the biome. Kind of like applying a coat of paint. Finally, we add features and structures, such as trees and ores and villages. In this presentation, I will focus mostly on the first step, terrain shaping. How do we procedurally generate terrain that is random, but also looks somewhat
Cool, man. See you, Speed. Have a good one.
realistic? How do we procedurally generate terrain that is random, but also looks somewhat realistic and interesting? Let's start with a very simple example. What if we just make it random? So the getBlock function returns stone or air with equal probability.
That's not gonna look good.
This is what we get. This is actually procedurally generated terrain. Not very fun or realistic, you can't even get around in there, but it is procedurally generated. But let's tweak it. Instead of just random, let's decide that the surface of the world is at y100. Y is the vertical dimension in Minecraft. So the getBlock function returns stone for positions below y100 and air for positions above. Dead simple. But now we actually get a world that you can move around in. And if we apply surface decoration, we get something like this. Better than before, right? But the world is still all flat and boring though. No rivers, no mountains, no oceans. All the worlds look the same. So our work is not done yet. Now that we have a surface height, we might as well randomly vary it instead of having it fixed at y100. In this case, we say that at each position, the surface height is 100 plus a random number between 0 and 19. One thing about the code examples in this talk,
Let's look
I've
at
simplified
what he's saying about
the overall
3D
terrain
noise.
height. But when it comes to the detailed shape of the terrain, that is actually done using 3D noise. Bear with me, I'll try to explain. The problem with 2D noise is that you can't get overhangs and super weird random terrain, the kind of terrain that Minecraft is famous for. So what is 3D noise then? How does that help us create super weird random terrain that Minecraft is famous for? Well, 3D noise just means a Perlin noise function that takes 3 inputs and gives 1 output. In our case, the 3 inputs are x, y, and z coordinate, and output is something that we call density. So each block position has a density value from
Yeah,
-1
this is
to
what I'm
1.
doing.
You can't see it anywhere in the game because it is used to calculate the terrain shape and then it is thrown away. Because it is a Perlin noise, the values change gradually, not suddenly. So what happens if we treat positive density as solid and negative density as air? You get a very strange but interesting world like this, some kind of crazy Swiss cheese cave world. Now let's apply a height bias. Density is decreased the higher we go and increased the lower we go. And there's a center point, say at y100, where density is left unchanged.
This is kind of what I have.
This effectively
Partly.
squashes the terrain. When we are high enough above y100, density will always be negative, and hence there will only be air. And when we are deep enough below y100, density will always be positive, and hence there will only be stone. This is how the base terrain generation is calculated in Minecraft. It is controlled by 2 parameters, squashing factor and height offset. If squashing factor is high, we get flat terrain. And if it is low, we get fractured, crazy looking terrain or even hanging blocks. Height offset moves the whole terrain up or down. So that is the base terrain elevation. Both squashing factor and terrain elevation are configured via terrain shaping, the thing I showed earlier, where spline points are defined based on continentalness, erosion, and peaks and valleys. So if you see some crazy looking terrain in Minecraft, that is because squashing factor is low, thus exposing the 3D noise. 3D noise is also used to generate the new cave systems. We use the same basic approach, giving each block position a density value. I'll illustrate it using 2D. Here's a noise field, again, like the TV static, but smoothed out, right? If we decide that
Um, could customize everything. Oh wow, yeah, maybe. Why not?
White is air and black is stone. Then this already gives us cool looking caves. We thought this looked kind of like Swiss cheese, so we call these caves cheese caves. They typically generate large caverns like this, and the size and shape of them can vary quite a lot. To create long tunnels, we apply another variant of the approach. Instead of saying that white is air and black is stone, we say that the border between white and black is air and the rest is stone.
Ah,
This gives us long
wow,
spaghetti-like tunnel
cool.
systems, so we call these spaghetti caves. It is slightly different in 3D, but you get the general idea. These tunnels can get very long. We combine these two approaches to generate interesting cave systems with a ton of variation in size and shape. In fact, I still get surprised quite often by the caves I find, even though I've worked so much on this. Okay, I've talked a lot about terrain shaping, and I'm going to wrap it up by talking a bit about biomes. A Minecraft world is divided into distinct biomes, such as jungle, or desert, or forest.
Got it, got it, got it. Nothing about
This is supposed to represent kind of how far inland are we. That's the mental model, right? High continentalness is we're far inland. Low continentalness means we're kind of offshore.
these videos
So
are
that's why as we are low here,
gold mines though.
offshore, terrain height goes way down below sea level. And that's how we get oceans. So this single thing basically creates oceans in Minecraft. It's pretty interesting. The side, we have valley surface, and what happens in there. Really well. But anyway, grid. What's hard about it, why does it matter? Because neighbors matter a lot. We don't want a desert to neighbor, for example, snowy peaks. It just looks ridiculous. So when we configure these tables, we think a lot about what biomes could neighbor which biomes. But it's a 5-dimensional configuration space, so each cell has 10 neighbors, which makes it really hard. But what's interesting is after a while, when you sit and work with this, your head gets warped enough so you start seeing things in as a 5-dimensional grid. And you get brain damaged. So for a while I was a bit brain damaged. I could be, outside looking at a slope there and seeing numbers in my head. Luckily, I think I've recovered from that now, feeling less messed up. But yeah, this kind of thing, I drew this. If you stare at it long enough, you either understand or you go insane. One of those two things happen. No guarantees offered. Okay, Random.
Basically the same thing.
No, I work a lot with this. I still.
Hmm.
For Voxly, they're innovating on voxel engine technology, the ability to actually make games, for example, and other interesting 3D projects
3D meshing.
just using pure voxels, right? So I think that's great. Lots of companies have tried and failed in the past to make voxels, pure voxel engine tech work, right? So they're trying to crack the code there. And then he has a talk called optimism and design. I don't want to spoil it. So
or 262,114 voxels. So now our voxel world is made out of 64 cube chunks, right? Well, what does our chunk look like in memory, right? We know what our voxel looks like in memory, but what does our chunk look like? Well, we might initially go with the idea of using a 3D array where we use a voxel's position to index into a specific voxel. But that's kind of annoying because whenever we want to refer to a single voxel, we have to lug around this position. So what we can do is we can take that 3D position and compose it into a single digit that we can use to index into a flat array.
Mm-hmm.
Well, how do we do that, right? Well, to start, we can break down our index into single axes, right? X, Y, and Z. We can compose it from there. So let's say we start with X. Right now, we're just creating our index from X. So any addition to X is really just an addition to index. +1 to X is just +1 to index, right? Which means index is only going to be 0 to 64 because we can only have X be 0 to 64 because our chunk size is 64, right? And next, let's add Z. We could have chose Y, but for the sake of iteration times and cache coherency, let's say we chose Z, right?
Mhm.
So since our chunk size is 64 and x is
Right.
already in the range of 0 to 64, what we can do is we can add z to our index without actually affecting our x value. Our x value is always going to exist in that 0 to 64 range.
That's a
where-
good
whereas
idea.
Z can exist in a 0 to 64 times 64 range, right? So whenever we add 1 to x, it's just actually adding 1 to index. And whenever we add 1 to z, it's actually adding 64 to index.
Yeah,
Z
that's
is
a really good
equal to
idea.
64. And that way we're not creating any extra voxels. We still have the same amount of voxels, right? Because we're creating a 3D volume. But we can still extract the parts we care about later on. So now we finally add y. So we've covered the range of 0 to 64, and then 0 to 64 times 64. So now we can cover the range of 0 to 64 cubed, right? So now any addition to y is really 64 times 64 in the index. So we can compose it all together. And now we have our finished formula, right? We have x, y, and z all adding to this formula. And we're only affecting specific ranges per type of axis, per axis direction. Well, how do we get our index back to 3D position? Well, since we are only affecting specific ranges when we create our index, we can also
Yeah.
extract those specific ranges when we want to care about a certain axis, x, y, or z, right? Or all together. And we can do that by, since x is actually just 0 to 64, we can see we can just take index and use the modular operator with
I wonder what the
64
performance
to extract the
improvement
0 to
is
64 range.
for doing
Since
this.
z only exists in a range of 0 to 64 squared, we can do the same thing where we divide index by 64, then use the same modular operator, and then we just repeat that process for y. So we're still representing a 64 cubed area, but we're now able to use a single position, a single index from this 3D position, right? So now we can define what our chunk looks like in memory. Instead of having that 3D array as before, we can just have a single index in a flat array, which is really powerful because now we just have this handle to this voxel.
Yeah.
But what about our world? Well, we can take the same concept we had before of taking a 3D position of a voxel and turning that into a single index and apply that to our chunks. We can take our chunks 3D position in the world and turn that into a single index into our world's own array of just chunks, right? And we can do this the same way we did it with 64 before because we knew our chunk size was 64. We can take the size of our ID and combine them. Well, how are we able to do this? Well, if we think about what data we're actually uploading to the GPU, it's just the position so we know where the voxel is in the world. 64 cubed, or our max slice that we might be doing this on, our max.
Yeah, if you do with
So now we just
voxels
make
like
this,
that,
system work by breaking we can go from 0.12
that could work.
milliseconds down to 0.01 milliseconds, where every single possible voxel can exist. And we can know where every single possible voxel exists because they exist on a uniform grid. We know where every single face can exist because they're all uploaded that, use that to test if it's air. And if it is air, don't texture, but if it's not air, you just have an adjacent buffer that's sparse with the types, and then you can get those types. So lots of optimizations here, right? So instead of having
Binary
to worry about
greedy
meshing, the
meshing.
simulation is the update itself. That means we could have massive world updates and not worry about meshing. We can set SDFs, run large simulations like a huge game of life, and do whatever we want, basically. And this is really powerful when you consider that also the only thing determining which voxels we're sampling.
This is supposed to represent kind of how far.
Hmm. Where is the bottleneck? Why is it in the wrong orientation? What if I add this now? Fill in below ground. What is it gonna look like? Looks kind of reasonable. Yeah. But it's doesn't reach all the way to the top. Why not? It should. Which part is this fill below ground. Let's do like plus 20. Generate height for XC height map. Get height for XC height map. And this is taken from our grid, right? Yeah. Oh, wait a minute. XC, is that where the bug is? Height map. No, it's not, right? XC. No, yeah. We only have X and C there. So what difference does this make? Nothing. So it doesn't seem to work for some reason. Fill in world grid below ground. It's doing XC. So for every two-dimensional, like if we're looking from the top square, we don't need them to be floats anymore. X, C, X, Y, C. Current surface height minus Y float. Can't we just do minus Y? Oh, no, let's just do if Y is below or equal to current surface height, then oh no, this is wrong. X. Current height minus Y. So this means the higher we get, the lower this value is going to become. Yeah, so it's going to become air. Actually, let's make this into a constant. So squash factor. What if I make it to 0.1? That should be a bit more interesting. Oh yeah, it just makes it higher. What if I make it to 1? Oh, that almost works. Still a bug here. Five. Yeah, it just goes out of range. And why is that? We have the Y height being 100. And we're setting the Y height when we're initiating the 3D grid. Yeah, X Z Y. Oh wait, grid 3D X Z. No, it should be XY. So we append, no, we need to move these as well, the order of them. For Y in range, X append, yeah, for every Y. No, like that, and then grid 3D XY append field value. All right, let's see what that does. That's very strange. Okay. And the height map is just an empty for every X and then for every Z we're initiating. Yeah, sure. Doesn't matter really, I think. We're setting X and Z in the height map. Trying to debug why this is not working. I don't need to make these into floats. X, Z, height map. X, Y, Z in the 3D grid, yes. And then get underground noise. X, Y, Z. X for Z. Height is elevate ground by plus get height for XZ height map. This should be plus 1 divided by squash factor so that we get above 1. Or wait, is that gonna work? No. Yeah, it should. It should. But okay, this is a bit weird. So we start at y is 0, and then we're going up to this here. Let's do +1. And we're doing this for a lot of y's. If y is below the current surface height, oh, wait a minute. We need to do elevate ground by here. And here, that's a bug. Or no, we don't need to do it there, but need to do it here. And this is wrong. X, Y, Z, and Y plus elevate ground by. Okay. Looks better, but not good. We should name this something better. Ground elevation offset or something. Oops. Why do I have stuff being generated in this direction when X and C are 16 by 16? It's a mystery. It is a mystery. Sorry? Oh, visitor streamer. That I've done arrays were faster. Fix the orientation bug. There is something. I mean, this must be, it could be the marching cubes, but it's just painting them in the wrong place. When it's creating the triangles, cube triangles. And how are we getting the cube triangles? Where is it called from? Create triangles, cube triangles. Wait. Get triangles. Triangle table. No. Somewhere we're giving them get edge vertex. Yeah, I think this is it. Yeah, here's the bug. X, Z, Y. I think. This would explain it. Yes. That's a lot better. Just need to fix the orientation of the triangles. But yeah, this is actually right. Could be. Nice. Okay, fix the orientation bug. Så det? Nej, det är bra tack. Fix the edge, no, fix the triangle orientation bug. And how do I fix that? It's probably here. Oh yeah, because I changed this spot, like X, Z, Y was how I had it. Now I changed it, so I'm gonna have to replace here probably, yes, X and Z. I think that should work. I think I've already done this. Maybe that's what caused the issue, or like, am I just recreating another issue now? 0. Zero. Good. This needs to be replaced. And then this one. And what does this yield? No. That didn't work. What's up with this? Did I mess it up with the... But I mean, this is salvageable. Just have to figure out the right combination. So let's compare with Git what I have here. All right, so 0, 0, and then 0.5 cube size. No, this is the same as I have. Zero 0.5 cube size and then 0. 0 cube size. Good, it's changed. 0.5 cube size 0. Changed. Cube 0. 0 cube. 0.5 cube. Cube 0.5. Cube cube. And then 0.5 cube. It's changed. 0.50. It's changed. 0.5 cube. Yes, it's changed. 0.5 cube. Cube. Cube 0.5 is changed. And then cube 0.5. Cube 0.5. Okay, let's try again. Okay, nice. It looks like it works, but it's inside out. Hmm. Why is that? Wait, I think I actually added something there to reverse the triangles calling or something. Or maybe that was the normal. Current triangles. And then what do we do after? Render triangles. No, we're not changing that. Okay, I think I would need to go through the world grid and look at that, you know. Oh, there's something up here. Cool. Yeah, so let's have a look. What the... Maybe I can just print it, like print the value where I'm currently at. And debug value in grid map v3 grid 3d v3.x 3.y 3.z. And then debug, so we do print. Then the player should call this get node. So when the game is running, where do we have it relative to the player? Okay, so just get parent. Var surface generator. Let's call it debug so we know it's a debugging thing. Debug surface generator equals get parent. Debug surface generator v3 no position.x Then we make it into an int. And then we do the same for all three. X, Y, Z. Dot. And what did we call it? Debug value in grid map. And that is printing the value. Okay, let's try this now. Again. No, wrong button. Command R. Debug value in grid map. Needs to be a vector 3, but I don't think that was the problem. Debug value in grid map. Why can I not access that? Okay, get node. What? Oh, maybe I haven't saved it. Is that the problem? No. What do we do with the camera? Then we do stuff with it. How do I reference other files here? Like marching cubes. I'm creating a new one, and that's my, but then we're editing it as a child. Oops. Surface generator. .gd. Yeah. Okay, let's try something. Just for debugging, the debugging tool. Print debug surface generator. Just to see what this actually contains. Oh, it's a flying player. Why? get parent. Let's try get parent. So where are we? Oh, okay, that's why. We are one step below. Get parent on get. This should work then. Yeah, so this is air. And here we are in air. Valid get index. Okay, I need to make some kind of check here. But if I go outside, I should try to go up and down within it, so to say. So like here, now I'm inside it. If I go below to like here, okay, this doesn't work at all. So here there should be something, but that's not represented in this, and here as well. So this should be solid, and this is not solid. And then from here on it should be solid again. It's not doing this correctly. So I need to debug. Now I know that at least. So now, yeah, I need to debug. Debug the world grid values generate this way of. Kind of looking for something where I'm not doing XYZ. XYZ, ground elevation offset. Light from map. X, Z, Y. Marching cubes. X, Z. Yeah, dude, I don't know. I see. Is this off? Get underground noise? No. There's actually things happening here on that border. It's air, solid. Air, air, air. Why is this not solid? Marching cubes is broken. Yeah, it is. Should be ground here, and then air up here. Ground, and then air. Ground and more air. Why are there so many fill values here? Let me check. Let's print the position it's using. Print v3. Oh, v3. Oh, it just updated. Yeah, this is correct. It's getting the right values. Just not sure why I'm filling it all with -2. And why does the ground go below? Why does it go below 0? It shouldn't. So maybe everything is offset for some reason. What if I do ground elevation offset 20? Maybe I need more. Let's also check, by the way, the height at the current position. Print. No, let's do it in the same one. Height at this position. Get height 4. v3.x, v3.z. Height. Oops. Why is that not working? Height map not defined. Oh. Global height map. What? What? Where does that come from? Okay, let's just do global height map instead. Okay, so the ground here should be at 3. It seems like it kind of is. Yeah. 5 here though. Yeah, 5 there. No, it's not correct. But if we look here, this seems to be more representing this. So it's like an offset of 8. It's like an offset of 13. Is it still an offset by 13? Yeah. So this seems to be possibly explaining the offset. What is it now? After function parameters. Oh. Seems to be an offset to the y and more things are not working. Cool. All right. I'm gonna stop the stream now, but yeah, good to be back. Thank you all for tuning in and coming to watch. I appreciate it a lot, and I hope you had as much fun as I did. It's great to be back. Bye bye.